So for the assignment, what we're asked to do is we're given one equation and we're asked to solve x and y. Now yesterday I told you that you can break these up into real and non-real components. And one equation could be 2x equal to 8 and 3i equal to negative 6yi. You can break those up. This is why complex numbers are used in reality with engineering and so on. X will just be 4, and what's y going to be? Well, you could kind of see you don't need to worry about these i's, and if you divide by negative 6, you'll get y equal to negative 1/2. Isn't that amazing? Now, use that knowledge for this 1b. X plus iy equals, expand this out, it'll be 4 plus 12i plus 9i squared. Well, 9i squared is the same as what? Negative 9. So this is going to be x plus iy equal to 4 minus 9, which is negative 5 plus 12i. Tell me what x is equal to. What's y equal to? Isn't that something? That's how we can use complex numbers to solve it. It literally breaks it into two different dimensions. Any others that you want to see from this set? Let's go to 4a and b. I'm going to give you a few moments now that you've played around with this a little bit. See if you can express the following in p plus qi form. That's the complex form. Just walk you through this one. You have foiling this, you'll get cosine theta times cosine alpha. Then you'll get I times cosine theta times sine alpha. Then you're going to get I times sine theta times cosine alpha. And lastly, you're going to get plus I squared sine theta times sine alpha. And of course, I squared is the same as negative 1. So I can erase this and call it minus sine theta sine alpha. How many got that far? Now what? Now we're stuck. Briette, you got an idea? Yes, cocosisi. Brilliant. Cocosisi. This is the cosine of theta times the cosine of alpha minus the sine of theta times the sine of alpha. And what's that the same as? If you put all that together, simplifies to the cosine of what? Theta plus alpha. Perfect. And then the rest of this is going to be plus I times cosine theta times, actually I'm going to reverse these, I think. I'm going to do this one first. Sine theta cosine alpha plus cosine theta sine alpha. Now that's times I. So this will condense into I times the what? What's seco cosi? Sine theta. And if this is a plus for sine, it is also plus. What? You mean if you are multiplying two complex numbers with theta and alpha, it's the same as adding? So multiplication becomes addition. What does that sound like? Sounds like, what's that? Yeah, and it also sounds like something you did in pre-calc, honors pre-calc, logs, doesn't it? Doesn't this seem very log-like? So mathematicians were thinking, wait a minute, if exponents kind of connect to complex numbers, maybe there's a connection between trig and logs. And we'll come back to that. We'll come back to that. All right, so you try this one. Cosine theta plus I sine theta over cosine alpha minus I sine theta. Now, does anybody want to take a wild guess on what this is going to be? Take a wild guess. When we multiplied, we added these. Want to take a wild guess what's going to happen when you divide? You think it's going to be subtract? Prove it. Yeah. You want to get rid of this I in the denominator. Did we have a strategy for doing that yesterday? Did I show you some way of doing that? We multiply by the what? We multiply by the same thing, but if this is minus, what do we do with this? That'll get rid of that for us. But in the top, unfortunately, we're going to have cosine alpha plus I sine alpha. Yep. This looks horrible. Oh, no. You're right. This is alpha, this is theta, and this is theta, right? Because cosine alpha minus I sine theta. Cosine alpha plus I sine theta. Cosine alpha plus I sine theta. Oh, wait a minute. I don't know why I thought I saw a division there. That's weird. That is so weird. Optical illusion. Jeez. That's crazy. Unbelievable. Okay, so now we're going to FOIL that. So you'll get cosine theta, cosine alpha. Is this the same thing? Oh, okay. Oh, interesting. This is good. So then you're going to get minus I cosine theta sine alpha plus I sine theta cosine alpha minus I squared, aha, there's your difference, sine theta times sine alpha. What will this minus I squared turn into? That'll change into the opposite of negative 1, which is the same as what? Positive 1, yeah. Okay, group these two and group those two and see what you get. And this will be minus cosine theta sine alpha. This turns into what? CoCC cosine of what? If there's a plus in the middle. Theta minus alpha. Are you getting good at these? Remember these from before? And then this is going to be plus I times, what's the seco minus cosi? Sine of theta minus alpha. Yep. By the way, the shortcut for this is going to be called cis theta plus alpha. And this one, the shortcut is going to be cis theta minus alpha. don't worry about that cis form. That'll make sense in a couple days. All right, one last one. Try number 5. Just so we're clear, what you're asked to do is find z squared. So you're going to go cosine theta plus I sine theta, and you're just going to multiply it times itself. I think you're doing that, but I just wanted to double check. So when I FOIL this out, I get cosine times cosine, or cosine squared theta. Then I get an I sine theta times cosine theta. And then I get an I sine theta cosine theta. And then I get an I times I, which is an I squared sine squared theta. And what was I squared again? -1. So that is going to be the same as minus sine squared. Grouping those together, I put the cosine squared and the minus sine squared theta together. I put the sine theta, cosine theta, plus the sine theta, cosine theta together, which is going to be how many sine theta, cosine thetas? 2 of them, right? So I'm going to take this out. I love the smart board. Oh, I don't love the smart board. Shoot. Thought it would let me do that. 2 sine theta cosine theta. Now, go back in your memory banks. What's cosine squared minus sine squared? What is it? Cosine what? 2 theta. And what is 2 sine theta cosine theta? Sine 2 theta. Now, doesn't it seem that if you had z equal to cosine theta plus I sine theta, we're going to call it cis theta, and you squared it, what does it seem that's like is happening here? It's like it gets, yeah, it's like it gets plugged in here. It turns into like a cis 2 theta because it's cosine 2 theta plus I. It's like this power comes sneaking in here. That's very what-like? Log-like, isn't it? We just proved that, but that's what's happening.